So we have 95 participants here. I hope the other people join by the Google live stream. Okay, so for today's session, we are going to learn the locating of a point by tacheometry. So I will first define the problem. We have the we are supposed to locate a station. Suppose we have a station A, and we are on the side of A. We are standing on O station, and we need to measure the distance from this instrument station to the station A. So there may be so many reasons, like there may be some river in between the instrument station as well as the station A, or there may be some slope of land due to which it is not possible to directly measure the distance from instrument station O to the station A. So for these type of problems, we will go for the tacheometric constants. So as I told you, we have the instrument station O located here, and we are supposed to measure the distance from instrument station O to the station A. It's not possible to directly measure the distance between 2 points. So uh, to measure the distance in the suppose we are placing a ranging rod on the station A, and we have already marked a distance on the ranging rod. Suppose if we know that distance between the point 1 and point 2 is 1 meter. Okay, and so we are sighting from the instrument station first to the point 1, and we will mark the angle from the horizontal line of sight. It will be alpha 1, and then we will sight to the point 2 on the station A. That will be noted as the alpha 2 value. So in this case, because as a both line of sight are above the horizontal axis, the included angle between the point 1 and point 2 will be alpha 1 minus alpha 2. So this is the main calculation. So we are using the theodolite to measure the vertical angle, that is the angle difference between the point 1 and point 2, in which we know the height of the we know the spacing of point 1 to point 2. So we will see the recorded video.
Today, our new work is tangential tacheometry.
Is my voice is clear to you now?
Yes, sir.
Yes, sir.
Is the YouTube audio is also clear to you?
Yes, sir.
Okay, thank you. So I just explained the problem, and this is how they did the same in the site on the field. So we have the instrument station O,
Here,
and we are supposed to
select
know
a
the distance
simple work.
between instrument station O, and we can see a ranging rod here. So this is a station A. Instrument station O is supposed to measure the distance between the instrument station point and this ranging rod point. Okay, so it's already marked some 1 meter on this ranging rod, which you will see in the video. Just listen.
That is using the tacheometric constants or the tacheometric relations, we can derive the distance between 2 points by tacheometrical differences and angle included with that difference points. Here we are set instrument at station O, and our target is far away from here, that is point A. On that point, we select 2 points. That means a certain distance apart from each other. That is, we selected it 1 meter.
ഇത് കാണിക്കാം ഫസ്റ്റ് പോയിന്റ്.
We can see the ranging rod at station A, and there is there is a point marked by chalk, and 1 meter below there is another marking point. Both are the same point, station A.
They're going closer to the range. You can see one point here marked with chalk, and here also we can see second
You
point.
can see the station point A. There is a ranging rod, and 2 points is marked there. One is at the top, and exact 1 meter below there is another point. The distance between these 2 markings is 1 meter. First we set the instrument and done preliminary setups and temporary adjustment. After that, we look to the point, top of the marking point. We can see the ranging rod. And parallax elimination, focusing, everything is done. After that, you done the exact bisection. Exact bisection. Using any of the upper plate or lower plate tangent screw, because we are not here read the horizontal angle, only vertical angle. So you can use either upper plate tangent screw or lower plate tangent screw for exact bisection. Now we take the vertical reading. The top reading is you can see the top reading is 4 degree 20 minute, 4 degree 20 minute and 40 seconds. You can write.
So you also can write parallelly how the readings are
4
recorded.
degree. Okay.
0 മിനിറ്റോ
Instrument at O, looking to A,
ആൽഫ 1.
and our first angle is alpha 1, that is 4 degree 20 minute 40 second. And in B scale, D scale, 20 minute 40 second. Write in the CD verniers, not write in the AB vernier, because AB vernier for horizontal angle and CD vernier for verniers is this. This is C and this is D. The main vernier is vertical reading. First we read only C, and after the exact clarification you read the D vernier also. So the angle is 4 degree 20 minute 40 second, and in D vernier 20 minute 40 second. That is alpha 1. That is alpha 1. Again, we look to the point, bottom point. And one thing, that is alpha 1 is angle of elevation. That is very important. You should mark it is angle of elevation. Angle of elevation, that is very important, because we want the included angle between the top point to this point and to the bottom point. That is the A dash. That is the angle, that is alpha 1. That is angle of elevation. The top reading is angle of elevation. And the second reading, we can, yes, this is the second point. After exact bisection, you can read the point. Only 40 minutes only in the main scale, and the vernier 11 minutes 20 seconds. So the reading is that is called as alpha 2, that is 0 degree 51 minutes 20 seconds. That's also 51 minutes 20 seconds. The first phase working is over.
Elevation.
That is also, you can see, this is 51 minutes 20 seconds. That is also angle of elevation. That is very important, because the difference between these angle is the included angle. That is, these two angles are angle of elevation. So the difference is the higher value minus the lower value is the included angle. If there is, the second point is angle of depression, that is minus reading, then you can this angle minus this angle, that means add this angle because for the included angle. These two are come in a same quadrant, so the difference between these points, these degrees, are the included angle. So now we are changing the face of the instrument. Now we change the instrument, transit the instrument, and rotate the instrument. So the face of the instrument now it is a right face reading. Do the same process, because it is for the exactness of the reading. If there is any change in the first reading or the second reading, if any change in the phase differences, you can eliminate this thing by taking both phase reading. Yes, exact bisection. Now the phase is changed. The C scale is here. Reading is 5 degree 40 minutes. 5 degree 40 minutes. There is only 40 minutes. So the reading is like this. It is alpha 3. We call it alpha 3. That is plus 5 degree 40 minutes 0 second 40 minutes 0 second. Now the lower angle. it is the point after exact bisection. You can read the second reading. Exact bisection 1 degree 40 minutes. Here it is 40 minutes only. The reading is 1 degree 40 minutes 0 second 40 minutes 0 second, and these two angles are, first angle is, you can see angle of elevation, the second angle is also angle of elevation. So we written as like this, and the difference between alpha 1 and alpha 2 is the first include angle, and difference between alpha 3 and alpha 4 is the second include angle. These two angles are different because the phase difference is there. So you can add these angles and divide by 2, you get the medium value or the mean value, and using this mean value you can calculate the distance between O and A. Without measuring this horizontal distance, you can calculate this distance. The equation D, distance is equal to S divided by tan alpha, and that alpha is equal to here it is alpha 1 minus alpha 2, or alpha 3 minus alpha 4, or alpha 1 minus alpha 2 plus alpha 3 minus alpha 4 divided by 2. That is the mean angle.
Face left, face right.
And the first two angle is alpha 1 and alpha 2. Here we take in the face left position, that is theodolite normal position, and the another two value alpha 3 and alpha 4 is face right position values. This is the face right position.
So, am I audible now?
Yes, sir.
Okay.
Yes,
So we
sir.
just watched the video. It was very clear.
Yes, sir.
So I'm just repeating what he told. So in the first case, both the value, that means he did for the phase left condition, alpha 1 for the point 1 and alpha 2 for the point 2. Then he changed the phase to the right, and then also he measured alpha 3 and alpha 4. Okay, so this C and D vernier, it is for the vertical angle measurement, A and B for the horizontal angle. So what he told is that if the both alpha 1 and alpha 2 are positive, we can know, like suppose this is the horizontal line of sight. If alpha 1 and alpha 2 are positive value, the included angle will be the difference between alpha 1 and alpha 2. Suppose think the alpha 1 is positive and alpha 2 is negative, that means alpha 2 is falling below the horizontal, then the included angle will be the it will be like individual sum of value alpha 1 plus alpha 2 without considering the sign, or it will be alpha 1 minus of minus alpha 2. Similarly, if the alpha, both the angles are in depression, then the higher angle minus lower angle will give you the internal angle. So from the theodolite and from the experiment, we are finding the internal angle between the two known points. So then after finding the internal angle, so we are going to measure D distance between instrument station O and station A. So distance D is equal to S divided by tan alpha. In the problem, it is given that the distance S is 1 meter. So 1 divided by tan of the included angle will give you the distance between station and the ranging road. Is it okay?
Yes, sir.
Any doubts? It's a simple
Yes, sir.
problem. Once you know how to measure the vertical angle from theodolite, it's just simple. Just do the procedure and apply the equation to get the distance between 2 points. Any doubts? So you can, I think you can copy this table. So this will be a more clear table, like instrument station, object station A, phase left, alpha 1, alpha 2, what is the degree, corresponding vernier values D, and for phase right value. So what I was telling is that the included angle measured from the phase left condition will be differed from the phase right condition. So you have to take the average of the internal angle. Okay.